Okay, good morning. Welcome to
FunMath149.
Is this 149?
I think so.
I think so too. I forgot to check. Alright, so today we're taking a tiny diversion
Yep.
from our problem solving algebra book because you asked me an interesting question that comes up in geometry, which is, do any 2 points form a line? Right? Now why'd you ask me that question?
Well, it looked like any 2 points form a line.
Looked like any 2 points form a line. So this gets into a little bit of history of geometry. So we got to go back all the way to Euclid. You ever heard of Euclid before?
A little.
You know when he lived?
In ancient Greece.
In ancient Greece, yeah, a long time ago. It's like
He invented geometry.
It's like 50 years ago. Or was it longer?
About 2,500 years ago.
Oh, about 2,500 years ago. Okay. So Euclid sort of wrote down some of the rules for geometry, and he wrote a really famous book. Do you know what it's called?
No.
It's called The Elements. So I think I might have that book somewhere on that bookshelf. But anyway, maybe we'll take a look. But he wrote down these 5 rules for geometry. So these are called postulates. And postulates just mean, here's what I believe to be true. You can't prove them. It's just what your rules are. So rule number 1, any 2 points form a line. So he just said, he was probably drawing on his whiteboard or his iPad screen or something like that. And he probably noticed that any 2 points formed a line. So he said, okay, let's make that one of our rules. Line segments, a line segment can be extended indefinitely.
Yeah, that's definitely true.
That means,
A line segment can turn into a line.
Yeah, draw a line segment. Okay, and then can you extend that indefinitely for me, please?
Okay.
Keep going. Okay, so it can extend it indefinitely in both directions. Good. Any line segment can become the radius of a circle. Give me your purple. Okay, so if I have a line segment, I can draw a circle with this one end at the center and the other end on the circle. Okay, so he just said that's a rule.
Or you could use it as a diameter.
Interesting. Well, here's what his rule was. Any line segment can be the radius of a circle. So now, how would you make it? How would you make a circle where this was the diameter? It's an interesting question. What would you do? Just tell me.
I just make the line segment and then draw 2 half circles around it.
Okay, how would you make a half circle though? You'd have to know where the middle was.
So you'd have to find the radius in order to find the diameter, though.
Okay, so you'd have to cut this in half somehow, but you can only use these 5 rules. So
Yeah.
we'll see if we can figure that out sometime. All right angles are equal. That's an interesting one.
Yeah, you can just twist the angles around.
Yeah, so he noticed that no matter where I had a right angle, it always looked like they were the same, so he just said that. And then he said parallel lines do not intersect. So if I have 2 parallel lines like that, they never intersect each other.
That's actually the definition of parallel lines.
Yeah, so that's interesting. That's interesting. He said it a little bit differently than this, but that's fine. He said he said it in Greek. But this one looks obvious too, right? They never get closer, they never get farther away, so they never intersect. Give me Neptune.
Okay.
Some people later on came and noticed.
Remember the spheroid, the all right angle triangle.
Yeah, so this doesn't always work on a sphere. In particular, these parallel lines on a sphere, you can draw lines that go from the equator, the North Pole to the South Pole, and wrap around the equator.
Yeah.
Okay. And these on a sphere are parallel lines.
Yeah, except they're not.
They always intersect at the North and South Pole. So in the 1800s, people noticed that these 5 rules don't always apply. These rules apply to geometry on a flat surface like our whiteboard, but they don't apply on a sphere. On a sphere, there's different rules.
Yeah, like the all like that.
Right. As you know, on a sphere, you can have a triangle whose all 3 angles are right angles. That's pretty interesting.
We probably show it with this bit of string.
Yeah. Anyway, so here's the rules. I just wanted to give you this little history lesson. We're probably going to do geometry in like 2 years from now, but this was a neat little diversion. Okay. Good job, sweetie. Good job.